itself off. But now what I'm going to do is I'm going to connect one of the meters. Oops. Oh dear. Let me try. No, I can't get to that one, so I'm going to take the easy course. I've disturbed the whole thing by trying to lift the tray clear of where one of the leads was connected. So I'm now going to connect one of the meters to the half cell in that position. That's the half cell over there. There, that's right. And I will then you can see the activity here. So what I'm going to do is I'm going to use the camera mobile and focus on the instruments. And then I'm going to, I've connected one of the instruments, this instrument, and I will now switch it. Let me see, how is this coming? That's amps. I don't want amps. I want this into volts, and I want it switched. Right, this is showing the voltage between the blue ground contact electrode and the blue pipe, which is very close to the electrode in the far corner, and that's showing 8.03. Now what I'm going to do, that is in voltage, right? So that's the potential difference between the electrode contact point and the metal of the pipeline. Now I'm going to move this to halfway across and poke it into the sand, and you see that the voltage there has dropped to 7.17. I will now move it again to the opposite corner, and it has dropped to 6. It's hovering around 6.50, 6.5 volts, and it is now close to the yellow coated pipeline. I will now move it across halfway down the side of the tray and hope it will stay there without falling in the water. It's now 5.92, and then I will move it up to the next position, which will be in the far corner of the tray, and I'll hold it there with my hands. That it is 5.24. Now I move it across to this position, which is in the middle of the far end of the tray, and now over the end of the yellow pipeline in the far corner, and then to halfway down the tray, which is close to the halfway down the side of the tray, which is close to the anode. Now I'm going to move it to very close to the anode, and it is around 8 volts, and now back to its original position in the corner. Hope it doesn't fall over. And it's 8.02. Now what I'm going to do is I'm going to turn the camera to focus back down on the tray, and zoom out again. Oops, wrong way. I've zoomed out. What I'm going to do now is show you where I have moved the electrode, half cell, call it what you want. Right, this was the first position, second position, third position, fourth position, fifth position, sixth position, seventh position, eighth position, ninth position, and the original position. Now what I'm going to do is I'm going to put it in this position. Hope it will stay there. Yeah. Right, now you can see the position of that. Good, yeah, that shows in the picture. I'm still recording. And I'm going to now show you again the instruments. And zoom in. Yes, and I can actually see that. Right, now, so that on this instrument, which is a multimeter, a simple multimeter, and it measures the difference in potential between this input and that input when it's set on volts there. Okay? So this is a potential difference or a voltage. Now whilst I've got it set up like this, I can, oh no I can't, because I've got one of the test leads trapped. Okay, I'll do that later. What's the pipe? No, I'll do that later. I'll put this back now into its original corner. Now this experiment shows you quite conclusively that it is the position of the contact between the electrolyte and the meter that determines the voltage, because during all these measurements the connection to the pipeline was exactly the same. So we were measuring the potential of the pipeline, which was the same, against the different positions of the ground contact electrode, that is called a half cell, and that determines the value that you read on the meter. So switch the meter